Okay, let me give you a couple more example. And this one, like we're gonna try to use the Laplace transform to solve this problem. But as you can see, this is still a homogeneous second order linear differential equation. So we can use characteristic as well. So let me do on the side and we can compare later, okay? Here we go. By the characteristic, it is r squared plus 1 equals 0. Then your r is plus and minus I, right? So which means it's imaginary number. Then your solution form will be a cosine t plus b sine t form. By the initial condition, you can find the general solution, not ut, sorry, it's yt. Yt is equal to 2 cosine t plus sine t. But like we're going to try to practice with the Laplace transform, then we're going to apply the Laplace transform, okay? Then it is Laplace transform of y double prime plus y, right? And lifting, it is equal to s squared ys minus s y0 and minus y prime 0. That's it, right? Then this can be written by s squared ys minus s times y0 is 2 minus 1 plus ys equals 0. Then let me get all the ys term, and we have s squared plus 1. And let me move like in the other part to the right hand side. It is 2s plus 1. Okay, divide by s squared plus 1 on both sides. Then your y is equal to 2s plus 1 over s squared plus 1. And almost said, okay, we're going to apply the like inverse Laplace transform. But before then, let me try to simplify your right-hand side, because that is 2 times s over s squared plus 1 squared and plus 1 over s squared plus 1 squared, okay? But, okay, that's it, right? So now, let me apply the inverse Laplace transform. It's like that will be your general solution, equal to 2 times inverse Laplace transform of s over 1 squared plus inverse Laplace transform of 1 over s squared plus 1 squared. Do you remember the like table? Just try to compare with table, and you can easily find this is number 6, and which is cosine function, and this is number 5, which is sine function. Okay, and your final answer is 2 cosine t plus sine of t, right? Like, when you compare with that blue answer, that is exactly the same answer.